Now continue the proposition. So we will prove the remaining results in the proposition. So the first result was integral over E AS plus BG, that will be equal to A integral over E plus B integral over E G. So this we have proved. Now we will show that if f is equal to g almost everywhere, then integral over f is equal to integral over E. Now, in order to show that integral over E is equal to uh, integral over f equal to integral over g, so it is enough to show that integral f minus g is equal to 0. So, that holds by this. അപ്പോൾ നമുക്ക് ഇതിനെ integral f minus integral g എന്ന് എഴുതാൻ പറ്റും. That will be integral of E integral over E f minus g equal to 0. So it is enough to show that integral over E f minus g is equal to 0. So let us prove this. We are given that f is equal to g almost everywhere. So f minus g will be equal to 0 almost everywhere. Now consider xi such that xi is greater than or equal to f minus g. So xi is a simple function, so consider the simple function such that it is greater than or equal to f minus g. F minus g equal to 0 ആണ്. So this will reduce to xi greater than or equal to 0 almost everywhere. Now if xi is greater than or equal to 0 almost everywhere, നമ്മൾ നേരത്തെ simple functionന്റെ properties കണ്ടപ്പോൾ there we have seen xi is greater than or equal to 0 almost everywhere, then integral over xi will be greater than or equal to 0. So we have seen this result previously in case of simple functions. So xi is greater than or equal to 0 almost everywhere, then in that case integral over xi would be greater than or equal to 0 almost everywhere. Now if integral over E xi greater than or equal to 0 almost everywhere, so integral over E xi will be greater than or equal to 0. Now integral over E f minus g will be the infimum of all these values. So if you have xi such that xi is greater than or equal to f minus g, അതിന്റെ infimum ആയിരിക്കും നമ്മുടെ required integral. So therefore since all for all psi integral over E xi is greater than or equal to 0, the infimum also will be greater than or equal to 0. So therefore we can conclude that integral over E f minus g will be greater than or equal to 0. And now similarly we can show that integral over E f minus g is less than or equal to 0. So that is by taking phi such that phi is less than or equal to f minus g. So we can look at the supremum in that case. So that will be integral over E f minus g. So that will be less than or equal to 0. So we will get integral over E f minus g greater than or equal to 0 and integral over E f minus g less than or equal to 0. So combining both we will obtain integral over E f minus g equal to 0. So we can write it as integral over E f minus integral over E g equal to 0. So that will give the required result. So integral over E f will be equal to integral over E g. So this proves the second result. Now the result 3 is modulus of integral over E f is less than or equal to integral over E mod f. So that can be proved using again this result. Okay. Now here we will have f less than or equal to mod f and minus f will be less than or equal to modulus of f. So this is by the property of modulus function. Now from the first inequality, so if you have f less than or equal to g, then integral f will be less than or equal to integral g. So from the same result applies for the second one also. So from the first inequality we will get integral over E f will be less than or equal to integral over E mod f വരും. Then രണ്ടാമത്തേത് minus integral over E f less than or equal to integral over E mod f. So here when you multiply throughout by minus sign, inequality reverse same, so we will get minus integral over E mod f, so that will be less than integral over E f. So combining both, we will get minus integral over E mod f less than or equal to integral over E f less than or equal to integral over E mod f varum. So that is same as modulus of integral over E f, that will be less than or equal to integral over E mod f. So that proves the result 3. Now the fourth result is, so if you have a and b such that a less than or equal to f of x less than or equal to b for all x belongs to E, then a into measure of E will be less than or equal to integral over E f, that will be less than or equal to b into measure of E. So we are given a less than or equal to f less than or equal to b. Now take a into chi of E less than or equal to f into chi of E less than or equal to b into chi of E. Now less than or equal to ആണ്. So if you have f less than or equal to g, then again integral f will be less than or equal to integral g. So using that, now apply the integral throughout. So you will get integral a into chi of E less than or equal to integral f chi of E less than or equal to b into chi of E. So here a and b are constants. So integral chi of E will be equal to measure of E, and here integral over E f into chi of E, that will be integral f ആയിരിക്കും. And this will be less than or equal to b into integral chi of E will be measure of E. So we will obtain the required result. So a into measure of E will be less than or equal to integral over E f less than or equal to b into measure of E. So that proves the third result. The fourth result and the last result is, so integral over f a union b, integral a union b f, that is equal to integral a f plus integral over b f. So let us look at the result. We are given that a and b are disjoint measurable sets with finite measure. So a and b disjoint measurable sets on, and they have a finite measure. Now if a and b are disjoint, then by the property of chi of a union b will be equal to chi of a plus chi of b ആയിരിക്കും. So integral a union b f will be integral f chi of a union b. Chi of a union b can be written as chi of a plus chi of b. So by the previous property നമുക്ക് integral രണ്ടായിട്ട് split ചെയ്യാം. So integral f chi of a plus f chi of b. Now integral f chi of a can be rewritten in the form integral over a f plus integral over b f. So that completes the so integral a union b f is equal to integral over a plus integral over b. So provided രണ്ട് സെറ്റ്സും disjoint ആയിരിക്കണം, and they must have a finite measure. So that completes the proof of the proposition. Now let us look at one more principle. So that is called as the Littlewood's principle. Now that talks about the convergence of a sequence of measurable function. The Littlewood's principle actually states that every convergent sequence of measurable functions is nearly uniformly convergent. So if you have a sequence of functions such that it has a point-wise convergence, then we can actually show that it is nearly uniformly convergent. So let us look at the statement of the Littlewood's principle. So let E be a measurable set of finite measure. So you have a measurable set E, and measure of E is less than infinity, and F sequence Fn is a sequence of measurable functions defined on E. So we have a sequence Fn that is defined on the measurable set E, and F is a real valued function defined on E such that for each x belongs to E, the sequence Fn of x converges to f of x. അതായത് Fn converges pointwise to f on the set E. Now, for given epsilon greater than 0 and delta greater than 0,